The reason for building SMAP, it's kind of pretty simple. Australia hasn't had a new backbone built since 2002. Was the last time anyone built a long haul network that was in a cap that was what I'd call of a significant size. We did an Indigo, but it was really just about extending Indigo West, which is Perth to Singapore, to Sydney, but nothing that was really designed to do the connectivity requirements I could see Australia needing for the next 10 years. I think one of the real hidden secrets in SMAP is the number of people it's actually going to benefit over time. And to give you an example, it really depends on how you're looking from the system. So if you think from an Australian domestic side, this is the first fibre cable, subsea fibre cable that's actually connected South Australia, certainly from a domestic basis, interstate, intercity. It's actually the first one that apart from a Basslink power cable, it's the first one that also connects Sydney to Melbourne subsea and Melbourne to Perth and Melbourne to Adelaide subsea. So Torquay and Melbourne's actually going to get some really massive beneficial. Victoria and South Australia are going to get massive benefit for extra resiliency and reliability. One of the really cool features about SMAP is we've integrated FibreSense into the whole platform. You can put a box on the end and it can see, well, it used to be about 50 kilometres down a fibre, you can now see 150 kilometres down a fibre. So what we've done with the integration on SMAP is we've actually put this in all the landings we have around Australia. You know, if you can see 150 kilometres away, you're off the shelf, which is typically the part that has the most chance of fishing or anchorage or some sort of activity. One of the challenges with FibreSense, it doesn't extend past the first repeater. And we have repeaters typically every 90 kilometres on the system. The first one that comes offshore is typically about 50 kilometres. So what we did, we put an extra strand of fibre in that to not just go to the first repeater, but to actually then another strand to go bypass the first repeater and get to the second. That gives us about 150 kilometres of range on that system. So that's a really key development, but it also not just goes from the beach manhole out, it actually extends from the cable station 150 kilometres. So it protects not just the cable station to the beach manhole, which is what we call front haul, so it looks for any excavation activity or anyone even just touching our network, and then it extends all the way out into the ocean. A real benefit of submarine cable systems, particularly fibre optic ones that we do these days, is they actually use very little power. So the SMAP system that's got 16 fibre pairs, Perth to Adelaide to Melbourne to Sydney, the amount of energy really required to actually just power the fibre and the cable that's in it, it's only about 10 to 15 kilowatts, which isn't much more than needed to operate a large home, for example. So that's one of the kind of things. So we're going to make sure that we're going to put solar panels and things on all the stations to do direct offset where we can at the station. But also when we look at the additional infrastructure that's required, the optical equipment, as we grow that over time, we'll be installing and implementing renewable infrastructure to offset that as well. So during the life of the system, it's really going to be a carbon neutral piece of infrastructure for Australia. SDM is something that kind of Google came up with, the industry adopted, called spatial division multiplexing. It effectively kind of allows the cable system to share pumps amongst each other. So if something goes wrong in the system, it's able to use some of the capacity from a pump that would typically be on another fibre pair, and they're in chains of 4. One of the reasons it's so important, it actually reduces the amount of power consumption that actually happens within a repeater. And that's what allows us to now go from what was typically 8 fibre pairs per system to 16 fibre pairs, and even now to 24 and beyond. So SMAP being the first SDM cable really lets us go to 16 fibre pairs and over 400 terabits across the system. So we're pretty happy that it's the first system to use it. Won't be the last, but it's the first, and it really allows us to provide more capacity for Australia and our customers. We've actually building is really 2 systems. So it's Sydney to Melbourne, and then a separate system from Melbourne to Perth. Then we do a branch from that into Adelaide, but we also do an interconnector between the 2 systems, between Sydney, Melbourne, Melbourne and Perth. And why is that important? Well, the branching units that we put in there are switchable branching units. So getting into, we have the capability, if a customer says, I want a fibre pair from Perth to Adelaide, we can switch it that way, and then Adelaide to Melbourne and Sydney to Melbourne to Sydney. So we're able to give people a system that's effectively what we kind of call that the milk run or all stations. So we can give them, using 1 fibre pair effectively, we can build 3 fibre pairs on a system that certainly suits it that way. But at the same time, if a customer really wants that pair just to go express between Sydney and Perth, we can configure the branching units for that fibre pair to go express. So some of the benefits for Australia is, as a nation, is going to be able to take international capacity from the United States or from Europe or wherever it might be, Middle East, Asia, take it into Perth, but then instead of it all going subsea to Sydney, we're actually able to take it express into Melbourne or express into Adelaide. And that's a really big thing, because there's a lot of infrastructure, both that's supporting data centre, but people as well, that we're for the first time going to be able to provide an entirely different, diverse route from international locations in there. And I suppose the way to look at it, it's in many ways, right now, the data centres of Melbourne and Adelaide, it's almost like if they were airports, they're domestic airports. They don't have an international runway. You can't catch an international flight there. What we're going to be doing here is actually being able to enable Adelaide and Melbourne to now become international destinations for some of the biggest digital infrastructure companies in the world. You know, building secure, reliable undersea infrastructure is really the cornerstone of what we do at SUBCO. That's why we often do sometimes the routes that are harder, because they're the better routes. You know, we go deep sea where we can, where we go shallow. Even when we went deep sea, we still did a layer of armouring. When we've gone shallow, South Australia is a good example. A lot through Bass Strait. Sometimes we were recommended single armour versus double armour. You know, we've typically made the call just to go double armour the whole way, and that's, again, real incremental investment in how we're doing this, to just give that extra level of protection. We want our customers to have the absolute faith that this, not just the cable, but the route and the way we've actually engineered this, is really focused on delivering the highest uptime that we can, and the most reliable service we can, and the most secure service we can. And that's really the hallmarks of what we do here at SUBCO.